Today we're going to be beginning our unit on evolution, and this information is going to be from chapter 16 of your textbook. I'm not going to lie, these notes are a little bit on the longer side, so I am going to break it up into two different videos. I'm also going to be going a little bit out of order. I'm going to start in chapter 16.2 of your textbook, and then I'm going to jump to 16.1, and then I'm going to go to 16.3. So the reason is that 16.2 talks about scientists that influenced Darwin's thinking. And I thought that that might be kind of interesting to delve into first, and then I'll go backtrack and talk a little bit about Darwin himself. So a little bit of history. Darwin was born in 1809. And fun fact, he was actually born the same day as Abraham Lincoln. And at the time, many researchers were starting to think a little bit differently about Earth and, looking at populations, geology, and other things on Earth, and Darwin as well. But these scientists kind of began to set the groundwork for what would become Darwin's theory, in that they, in their own right, had major discoveries that helped Darwin to say, you know what you're saying is going to help what I'm saying. And I'll get more into that in just a second. But let me start off with a guy named James Hutton. He was a geologist, and he did most of his work in the late 1700s. And he began to think that the Earth was definitely a lot older than a few thousand years, which, believe it or not, at the time, a lot of people believed that that was fact. And he argued that the Earth was very old based on some observations. And they were that sediments can build up and form rock. And you can see that in places like the Grand Canyon, where you get layers, and over time, these particulate layers will solidify and become rock. But the thing is, that takes a really long time to do. He also noticed that rock could be made from lava, like in volcanic eruptions. And over time, the Earth's surface can push these layers upward and twist them and bend them, which can create mountains. And mountain formation also takes a really, really long time. And then eventually you can see these mountains be worn down by weathering processes. And all of this kind of builds on the fact, or leads up to the fact, that Hutton believed that the Earth was very old. And he didn't necessarily have a number, but what he called it was deep time. It was essentially so old that it's hard for a human to fathom. And it's definitely not just a few thousand years old. Charles Lyell was another geologist who expanded on Hutton's ideas. And he wrote a book that actually Darwin read, and it was called Principles of Geology. Now, you're going to see that I'm going to do this take home for Darwin. And what I mean by that is, how did these scientists influence Darwin? And the take home for Darwin, for both Hutton and Lyell, was that the Earth was so old that it was enough for his theory of natural selection to work. Because for Darwin, natural selection, and I'll get into what that is later, needs a lot of time to happen. And Darwin said, you know what, if these scientists are saying the Earth is much older than a few thousand years, that makes sense, because in order to get these new species that have evolved over time, it would take a long period of time through natural selection. Another scientist that influenced Darwin was a man named Malthus, Thomas Malthus. He was an economist, and he noted some really interesting facts about the human population. And even though this is not exactly ecology or environmental biology in a way, Malthus's ideas also influenced Darwin. Now, what Malthus noted was that humans were being born faster than they were dying, and that's still happening today. And that caused overcrowding in cities. The human population could, and currently is, growing unchecked. There are forces that act against this growth, which we now call selection pressures. And they are things, and for him, he was just looking at the human population, but like famine and disease. But these are also selection pressures that act against other populations in nature. Now, what was the take home for Darwin? High birth rates and selection pressures do occur in nature. More babies are born than can survive, and Darwin wondered, why did those that survive make it? What was so special about the ones that survive and live and pass on their traits to their offspring? Why did they survive and others possibly not survive? Another scientist that influenced Darwin was a man named Lamarck. And Lamarck essentially was publishing his most notable works when Darwin was born. So he's essentially like a generation older than Darwin. And he was French. He was a naturalist. And what was interesting about him is he did believe that organisms could change over time. Their traits were indicative of the environment that they are in. So that's good. However, Lamarck gave a relatively poor explanation as to how that would happen. His explanation was that organisms would selectively use or not use or disuse of their body parts. And if they used a body part more or didn't use it, it would cause them to acquire or possibly even lose a trait. And so his theory was that of what's called acquired characteristics. And when I say acquire, it means you can obtain. You can obtain a characteristic. You can obtain a characteristic by habit. Okay, so something that you choose to do or not do can change your body plan or your body style. So Lamarck was one of the first naturalists to suggest that organisms are not fixed. They can change over time. However, the explanation by which they can change over time was poor. He said it was by habit. And the most famous explanation was how Lamarck explained giraffes and their long necks. He said that there was an original shorter-necked ancestor, and through its habit of trying to reach its food, so by stretching its neck, over its lifetime, its neck grew longer. And then, when this giraffe had babies, the babies also had long necks. Okay, so again, the habit of the organism changed its body, and then that body change was then heritable. And that is not how it works. That's like saying if I go work out every day and my muscles get bigger, that means that my children more than likely will have bigger muscles. which is obviously not how that works. Now, what was the take home for Darwin? Lamarck's explanation of organisms changing over time was poor, but it inspired Darwin to craft a better explanation of why this change occurs. Now, the next section just goes over Darwin's history, and this is in chapter 16:1. So I'm going to backtrack now and jump and talk a little bit about Darwin. So after he finished college, he traveled on a ship called the Beagle, and it's spelled a little bit different, Beagle. And that Beagle trip is outlined in your textbook, so it's a clickable diagram, and you can kind of look and see the path that the Beagle took. But in his travels, Darwin noted some really interesting things. First of all, he saw species all over the world, and he noted that even though, for example, large flightless ground birds were found in many parts of the world, they were similar, but separated. And they were often found in ecologically similar habitats. So a great example is the ostriches found in Africa. Rheas are found in South America. The emu is found in Australia, and then there's a couple of others, one of which is extinct now. A couple, are extinct. What we know now is all of these large ground flightless birds, notice, are found for the most part south of the equator, and they are all in continents that were at one point joined in a very large continental mass called Gondwana land, or Gondwana. And as those continents separated, the populations became separated and eventually evolved over different lines. But the theory is that they were all fairly closely related and possibly originated with one common ancestor. So Darwin saw these birds, and he's like, oh, that's really weird. You know, this bird is over here, and this bird, I remember, was on that continent. And they have similar ecological roles, similar diets. You know, some of them are found in similar habitats. When Darwin got to the Galapagos Islands, he noted that the islands had different ecological habitats, and funny enough, there were these small little finches with different species being found on different islands. And he began to wonder, since they were so close to each other but on different islands, could they perhaps have been members of the same species at one time? It's a little bit hard to see, but if you look on the picture of the right, you can see some of the different islands on the Galapagos, and notice that the plant life varies on some of the islands. Some of them are a little bit more lush and tropical, some of them are more desert-like, and that has influenced the type of finch that can survive on that island. So Darwin noted that the island habitats varied, and so did the species of finch that were found on each of the islands. So I'm going to stop here, and in my next video, I will go over Darwin's theory that was published when he returned from his trip in a very famous book called On the Origin of Species.